Generalized linear models. So we'll do the past year questions here. Show that the discrete distribution belongs to the exponential family of distributions and derive expressions of the mean and variance of the distribution, expectation of I and variance of I, using your answer in part 1. So let's do this from the definition of Fy mu. So first write question 1, and f of y comma mu is equals to e to the power, or you can just write exp. There no need to write e to the power and complicate yourself. You can just write e and then just write y n log y space n log space mu backslash, come out of the highlighted region, plus 1 minus y log 1 minus backslash of mu, come out of the highlighted region, brackets close, log of 1 minus mu. Yeah, so here there will be a bracket over here, and then there will be one more bracket closing for this, and then one more bracket for the final one, and then plus log of n. Now see how to write nc ny, n backslash a top, and then you write ny. So don't give space first, n backslash a top space and then ny space. This is how you write this, a top and brackets close. Okay, this is there. We had opened a bracket over here, e to the power n, and then ny log mu plus 1 minus y log of 1 minus y, one brackets close here, then one brackets close, log of 1 minus mu. Just a second, one more bracket I will need. So this has come inside this. Okay, no issues. You can just normally give one bracket even if it doesn't happen. Okay, no need to think so much about the brackets. The only thing, it should be correct. And exp again n y log backslash mu divided by 1 minus mu brackets close space brackets close space plus log of 1 minus backslash of mu brackets close. Okay, plus log of n a top n y brackets close and final brackets close, and so on. Okay, hence backslash theta is equals to log of mu by 1. Now these are direct derivations, may or may not come in the exam also. Okay, backslash phi is equals to n backslash a of phi is equals to 1 by phi, and then alt equals to b of theta is equals to log of 1 plus e to the power backslash of theta, and last one is c of y comma phi is equals to log of backslash of phi comma backslash of phi y. Let's comma by. So these are the values we have. Okay, so this is proved exponential distribution, and part 2 we need to calculate expectation of y and variance of y. So from theory we have expectation of y is equals to b dash of theta is equals to log of 1 plus e to the power backslash of theta, which is equals to e to the power of theta by 1 plus e to the power of theta. You can copy e to the power theta also every time, no need to write. I am just writing. So this gives you mu, and the last portion is variance of y is equals to a of phi into b double dash of theta, which is equals to 1 by n e to the power theta divide. Again you can copy this e to the power theta 1 plus e to the power theta from above, okay, instead of wasting time on writing. So equals to 1 by n, and now I will not write. Equals to this into this, basically opening now, and 1 minus control v e to the power theta less than theta equals to what happens, backslash mu 1 minus backslash mu divided by n. So this is our answer for variance of y. All has come from above, from what we have been writing. Okay, so this is done. Coming to next question. For a certain portfolio of insurance policies, the number of claims on the ith policy in the jth year cover is denoted by Yij, the distribution of this, where the theta is this. Derive the maximum likelihood of a theta ij given the single observed data, and write Pij in exponential and describe the different characteristics of Pearson's deviance residuals. So first, coming to next page, which is question 2, we have to write, and then starting off from here. So first, part 1, the likelihood is given by L is equals to backslash theta underscore ij 1 minus backslash of theta underscore ij to the power y underscore ij. So this does not work like this. Brackets mein y underscore ij you have to write, so that this works like this, and then taking log on both sides, we have been given log L is equal to, come out of this, log of backslash of theta underscore ij plus y underscore ij 1 minus backslash of theta underscore ij. Okay, differentiating alt equals to backslash partial del log L, okay, divided by partial del theta underscore ij is equals to 1 by del theta ij minus y underscore ij divided by 1 minus backslash of theta underscore ij. So this is there. Setting this to 0, we have alt equals to 1 by theta underscore ij is equals to y underscore ij divided by 1 minus back theta underscore ij, and then just solving for this, all equals to 1 minus backslash of theta underscore ij is equals to y underscore ij plus theta underscore ij, or all equals to theta underscore ij is equals to 1 by 1 plus y underscore ij. Okay, so this is there, and then we have to check for maximum. So what I'll do is, I'll not write anything, I'll just copy this, paste this. So del square by del theta square, okay, is equals to minus of 1 by this, every by i's also we know this is minus of 1 by theta ij square, and this also becomes square. Since the entire thing is negative, we have 0, hence maximum. Okay, and next part is part 2, where we have to calculate probability of y underscore ij equals to y is equals to backslash of theta underscore ij into 1 minus backslash of theta underscore ij to the power y. So now solving for this, we have exp of log of backslash of theta underscore ij plus y of log of 1 minus backslash of theta underscore ij. Okay, coming down, then which is equals to exp of y log 1 minus backslash of theta underscore ij plus log of theta underscore ij. Coming to next line, coming down, this finally becomes exp of y backslash theta minus b of theta divided by a of backslash of phi plus c of y comma backslash of phi. So where all equals to backslash of theta is equals to log of 1 minus backslash of theta underscore ij is the natural parameter. Okay, and alt equals to b of theta is equals to minus log of backslash of theta underscore ij, which is equals to minus of log of 1 minus e to the power minus 1 minus e to the power of theta, and alt equals to phi is equals to 1, and alt equals to a of backslash of phi is equals to 1, and alt equals to c of y comma backslash of phi is equals to 0. Okay, and the last says define Pearson and deviance residual, which is a theory, and you can write it. Okay.